Welcome to my video on the second part of 3-5, which is systems with 3 variables, but with a focus on word problems. So we're going to apply the skills of the last lesson to word problems after we have translated everything. So to do this, we're going to focus on number 30, which was on the homework. Number 30, let me just add a page, says, in a factory, there are 3 machines, A, B, and C. When all 3 machines are working, they produce 287 bolts per hour. When only machines A and C are working, they produce 197 bolts per hour. When only machines A and B are working, they produce 202 bolts per hour. How many bolts can each machine produce per hour? So, to do this particular question, the first thing we need to do is address what our variables are, define them. So we know we have machine A, B, and C, but what is the question specifically asking about? Well, it's specifically asking about how many bolts each machine can make. So variable A stands for number of bolts for machine A, right? The number of bolts machine A can make. B stands for number of bolts machine B can make. And C is number of bolts machine C can make, okay? So our answer talks about bolts. So now if we take this sentence by sentence, we should be able to kind of create a system with 3 different situations. So the first sentence says, in a factory, there are 3 machines, A, B, and C, okay? When all 3 machines are working, they produce 287 bolts per hour. So in order to be able to do this, remember, we have to add the total number of bolts, A plus B plus C, and they have to equal the 287 bolts per hour. Sentence 2 says, when only machines A and C are working, they produce 197 bolts per hour. Okay, so what does that mean? Well, I'm going to add A and C, because those are the only ones working, and that has to be equal to 197. Sentence 3 says, when only machines A and B are working, they produce 202 bolts per hour. So if it's only A and B, right, I'm only adding those 2, and they are equal to 202. All right, so now I have a system. You will notice that I have left spaces, right? If there's a missing variable, I will often leave spaces, because if I choose to do elimination here, my variables have to be stacked. Now, I'm not going to do elimination here because I want to demonstrate substitution, because one of my variables are missing. Okay, but it's absolutely possible to do elimination as well. So if I do substitution here, I'm going to probably choose either one. Let's choose this equation and solve for A. Okay, A plus C is equal to 197. So if I move a C over, I get minus C plus 197 is equal to A. I can now take that value and plug it into both equations to create a new system to solve. So in A plus B plus C, I get minus C plus 197 plus B plus C is equal to 287. When I combine my like terms, I'm lucky. My C's will cancel out. And I end up with B plus 197 is equal to 287. And I can then subtract. Okay, so in an effort to try and use substitution, I ended up actually getting one of my values of 287 minus 197, 90. Okay, so now that I found B, I'm actually going to be a little strategic here. I'm going to go to this third equation, A plus B, because since I have B, I can find A. So A plus 90 has to be equal to 202. So I subtract 90. And I get A is equal to 202 minus 90, which is 112. And so last but not least, I have to find my c. So I can substitute it into either equation 1 or equation 2, but I'm going to be strategic again, and I'm going to plug it into equation 2, which is 112 plus c is equal to 197. So if I subtract 112 from both sides, I get c is equal to 197 minus 112, which is 85. So what does my answer tell me? Well, A produces 112 volts per hour, B produces 90 volts per hour, and C produces 85 volts per hour. Okay, so let's try one more word problem before we go, but we're just going to make the equation for this, and I'm going to challenge you to solve this on your own. Okay, a stadium has 49,000 seats. Seats sell for $25 in section A, $20 in section B, and $15 in section C. The number of seats in section A equals the total number of seats in section B and C. Suppose the stadium takes 1,052,000 from each sold out event. How many seats does each section hold? Okay, so first we have to define our variables. A is the number of seats in section A. B is the number of seats in section B. And C is the number of seats in section C. All right, so if we again go sentence by sentence, we should be able to fix this equation. Okay, so a stadium has 49,000 seats. So that means all the seats in total. So if I add the seats in A and B and C, it has to be equal to 49,000 total seats. Second sentence tells me about money. Seats sell for $25 in section A, $20 in section B, and $15 in section C. And the stadium takes in $1,052,000 from each sold out event. So if I combine those two sentences together, right, I can multiply 25 by the number of seats in A, 20 times the number of seats in B, and 15 times the number of seats in C. And that has to be equal to 1,052,000. And for my last relationship, the number of seats in section A equals the total number of seats in section B. Okay? A has to be equal to B plus C. Okay, so those are my three equations. Now I suggest you try substitution by substituting B plus C in for A here and A there and solving. Okay, if you wanted to do elimination, remember A's have to be in column, B has to be in column, and C has to be in column. So we would need to adjust this equation to be A minus B minus C is equal to 0. In the end, you should get, I believe, 24,500 for A, 14,400 for B, and 10,100 for C. Try it out and check your work. When you're done, you can work on the worksheet 3-5, practice and word problems, and complete questions 1 through 7.